6. So I needed to change some numbers. We're going to have Mary push with 50 newtons. We're going to have the sled weigh 400. So here's the situation. We've got a sled with a kid on it. One kid's pulling it, and that's Joan. And then we have Mary kind of pushing it from behind like this. So I'm just trying to draw Mary pulling the sled. I know this is a really bad drawing, but just bear with me here. So let's clean this up with a free body diagram because this just looks terrible. So we're going to have Joan pulling, Mary pushing, friction fighting things. We got a normal force and we got the weight. So let's set up our balanced and unbalanced equations. So we know normal balances gravity. And since we know the weight is 400 newtons, that means the normal force is 400 newtons since they balance. The other thing that we have is that Joan and Mary work together to fight the friction to make the sled accelerate. So one thing we can do here is with this is first we can get the friction. So we know friction is mu times the normal force, and that's going to be 0.2 times 400, and that's going to give me 80 newtons. And now let's get the weight of the sled. So we know Fg is, sorry, the mass of the sled and the rider. That's Fg is 400, mg is 400. We know that g is 10 because g is always 10, so that means m is going to end up being 40 kilograms. So we can plug all that in there. Also, we were told that Mary's pushing with 50 newtons, so we know that's 50. When we put all this together, we're going to get Joan plus Mary's 50 minus the 80 from friction makes this 40-pound sled accelerate. Now we need the acceleration. Let's go ahead and get that up here. So we know V equals AT plus V naught, and we're told the sled starts from rest and takes 8 seconds to reach that speed. So we know 5 is going to be A times 8 plus 0. So A ends up being 8/5 or 1.6 meters per second squared. I'm going to use the former because it cancels a little fraction stuff for me. So 40 times 8 over 5. That cancels to give me 8 there. So I'm going to get J ends up being 94 newtons of force that Joan pulls with. And that's the answer to number 6.